Good morning. I hope that, Lauren, that you had a great weekend. It looks like it might just be the two of us today. Camille is acting up this morning, so I wasn't able to send a reminder yet. It's not letting me message students. Kind of strange. But what we're going to cover today is the beginning of Unit 5. It will be approximately 5.01 to 5.04. 03 and 04 you're learning about this week, so I'm doing a little bit of prep work with you guys. So some of the stuff you haven't seen quite yet. So I'm hoping that it will just make it not so scary once you guys get there later in the week. So let's jump on forward. Here is your Week 17 essential question. It says, what does a histogram show you? Which is a very straightforward question once we get there later in today's session. So we're in Week 17. We only have a couple weeks left to go before finals, so we're really kind of winding down at this point. Okay, so here's some vocabulary that you will definitely need to know before your test. We're going to cover the first three today, mean, range, and standard deviation. The last two will be covered next week. So let's start with some basic vocabulary. Now some of the formulas this unit are really scary until you kind of break them down and you have a better feel for what they're asking you for, then they're not so bad. So let's kind of take a peek at how the book explains it to you, which again, scary, but it's really not that bad once we break it down. So what this says is our mean. You've been doing mean probably since 6th or 7th grade. Mean is the average. That's the way that I like students to remember what it is. Mean is the average. How we find the average is we add all the numbers together and then divide by the total amount of numbers. You're used to this back from 6th, 7th grade and so forth. Now that we are in Algebra 2, they're using sort of our Greek symbols to help us talk about the mean. This whole nonsense means find the average. This is just an algebraic way to put it. So from now on, you're going to see when they want you to find the mean, they're going to show it to you like this, an X with a little line on top. When you see that symbol, that means find the mean. What does mean mean again? You add up all of your terms and you divide by your total amount of terms. So if you have 10 terms, you add all 10 together and you divide by 10. That's what this crazy nonsense means, right? This was our sigma notation that we learned, and sigma just means to sum it up. That's all we're doing. We're summing them up, dividing by our total. So mean and this are the same thing. They're just showing it to you in an algebraic form now. Looks a little scary, but it's really not. Nothing you haven't done before. So here, if I say find the mean, notice that I can do my X with my little line on top. To find the mean, I add them together, and then because there are 4 terms, I divide by 4, and I get 20. So that's what we just did. We just did this crazy thing. We did the sigma notation because we started with our first term, we went to our 4th term, and we're adding all 4 terms together, dividing by 4. All right, median. So we have kind of 3 vocabulary words I'm doing on this page with you: mean, median, and mode. So median, use the word to help you. Median sounds like middle. It means the very middle number when they're placed in order. So let's try one. If I say find the median of 24, 26, 13, 17, first you have to put them in order. And then if I want the exact middle, there isn't a middle number because there's an even amount of numbers. So I have to find the middle of these 2 numbers. How do you find the middle of 2 numbers? Add them together, divide by 2. So I would get 20.5. So sometimes if I say find the median of this, see how I have an exact middle number already for my median? That's easy. We like it when they give it to us with an odd amount of numbers because there's one smack in the middle. But when I have an even amount, the number right in the very, very middle is between those 2 numbers. So that's when I add them together, divide by 2, and that's the very, very middle of your set. Are we okay with that when we have an even amount versus an odd amount? How to find the middle? You did great on your quiz on that one, by the way. Mode means most. See how it kind of sounds even like the word mode? Mode means most. It's a value that occurs the most. So if I'm looking at this set down here, The number that occurs the most would be 2. So let's look at our 3 one more time. Mean means the average. Median means middle. Mode means most. They kind of sound like themselves. These are called measures of center. So there's a couple ways we can display this data. The first one is a stem and leaf plot. And the way that you do that is, like, let's take these numbers right here. And again, this is a review that you guys should have done last week. So it's a quick review. If I take all of these numbers, basically what they do is they put the tens column over here on the left and the ones column on the right. So if I'm trying to represent 77, it would be a 7 over here and a 7 on this side. Tens column, ones column, 77. This is 78. This is 78. 78 is listed twice because I had 2 of them. So by looking at this chart, you can find the median. Median would be the number in the very middle, so we just have to count to the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be the one that's in the very middle, 82. Mode would be the number that shows up the most. Now notice you can have 2 modes. So here I have a 78, 78, and here I have an 82, 82. So since they both showed up 2 times, you would write them both. And then for your average, mean means average, you would just write them all out just like normal and divide by the total amount of numbers that there were to find your mean. Remember the other way to represent your mean, it's the X with the line above it. So our stem and leaf plots, okay, not too bad, just a different way of representing some data. Okay, now we get into variability, and here's where they like to use a lot of terms with you guys that I don't want you to get hung up on. So range. If you think about on a graph, our range on a graph was how high to how low our graph went. It's the range of numbers. It's the same here except not on a graph form. It's the difference between your greatest and your least values. So if I have all these numbers, 2, 5, 7, 10, and I say what's the range, it'd be 10 minus 2. So my range would be 8. It's the span of your numbers, the difference between the greatest and the least. Now here's where we can split up our data. There's a couple ways to do it. They're going to give you a name for this in a minute, but this is called your 5-number summary. Oops. Summary. And this is what goes on a histogram. Can you add that to your notes? Because this is your essential question for the day. Your essential question was, what does a histogram show? Here's what a histogram shows. It shows your 5-number summary. What's included in your 5-number summary, we don't really need this portion. I'm going to show it to you a little bit more clearly down below. It's going to show your max, your min, and your 3 quartiles. So the way that we put it, we say min, max, and then we have Q1, Q2, and Q3. So I'm going to help you with this in just a minute. We're going to make a 5-number summary. So if here are my data points, the first thing we do is write them in the correct order, so from least to greatest. Because again, you can't find your mean, your median, any of those things until they are in order. So let's put them in order. Can you give me a green check mark once you have them written in order? And then we'll do the next step together. All right, excellent. So let's take a peek at some of these numbers here. The very first thing, so I know I'm going to have a min and a max. My min is obviously going to be my smallest. My max is going to be my largest. So let's write those underneath those numbers. Here's my min, here's my max. Those two are super easy to find. So check mark, I did those first 2. Now quartile 2, and quartile 3, the way that we find those is we're going to start with quartile 2. Quartile 2 is your median. So if we want to call quartile 2 our median, that's fine. So median is our number exactly in the middle. So if I'm counting over to the middle, I can count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, the middle of 11 would be 5. The other way you could do it is you can cross them off. So I keep crossing off ones from each end until I get to the very middle. So that would be my Q2. Here's how you find your Q1 and your Q3. Quartile 1 is the middle of your first portion of numbers. Your quartile 3 is the middle of your remaining numbers. So here I'm going to section it off with a highlighter. So what would be the middle number between 77 and 87? Well, the very middle of those, see if I cross off the 77, 87, cross off 80 and 85, this green 85 would be my middle of those values, Q1. Notice you don't use your median number. The median is not included when you're trying to find your quartile 1. That's why I put my highlights just between these two numbers. So if I put my highlights on the other side, between 90 and 100, what's my very, very middle number? 95. So that would be my Q3. So that's how you find your 5-number summary. Again, your min, your max, Q1, 2, and 3. Q2 is just your median. And then once you have your median, Q1 is the middle of the remaining numbers. Q3 is the middle of the higher remaining numbers. So to put these on a graph, which you guys did already have a quiz on this, the first one is just a dot, second one is just a dot. These other ones form a box, just like that. So that's where those numbers go. Dot at 77, a dot at 100. Your Q2 is a line, your Q1 is a line, your Q3 is a line, and you draw in your box and whiskers plot. They call it box and whiskers because of what it looks like. It looks like a box in the middle with 2 little whiskers sticking out. Any questions on that one? So this was all last week's stuff. Now we're going to get into this week's stuff, which is finding standard deviation and sampling. This word called variance and standard deviation, okay, so first let's read this. To give us an idea of how spread out the data is, we calculate variance and standard deviation. Variance V is standard deviation squared. So what standard deviation really is sort of like the distance from your median, the distance from your middle value. It's telling you how spread out your data is. So this thing looks crazy scary, and we're going to do this together. Let's really think about what this is here. What this is we know that this means to sum. I'm going to be adding up a whole bunch of things. And then what am I adding up exactly? Well, remember what xi means. Xi is whatever term they give us. So if they give us, and we're going to practice in a minute, if they give me a 127, a 130, and a 132, I have to do this 3 times. The first time I'm going to try it with the 127. Second time I'm going to try it with the 130, and the third time I'm going to try it with the 132. That's what the xi stands for. Each individual term is going to go there. Then this x with the line above it, Lauren, is where you are exactly right. This x with the line above it, just this portion is the mean. That's the average. So I would find the average of these, and that number would go in right there. So we're going to try this together. I just didn't want you looking at this and thinking, oh my gosh, this is super duper scary. It looks scary, but it's not as bad as it seems. The x with the I is the average, and then in x sub I, we're going to plug in each individual term that they give us. So let's try this together. Here's where it looks scary. It's really not that bad. So I'm going to cover this. Cover this, cover this. I don't want you getting overwhelmed at all. Okay. I want you to make a chart on your paper that looks like this one. And anytime they're telling you to calculate variance and standard deviation, this is the chart that I want on your paper. So do 3 columns. We want an x sub I column, an x sub I minus x with the line over it, and then an x sub I minus x with the line over it squared. So let me give you a minute. Make this little chart on your paper. And just give me a smiley face when you're ready. Okay, so far we're good. We see the word variance, we see the word standard deviation. You're thinking, Miss G taught me to make this chart. That's exactly what I want you to do. Next, what's going to go in the X sub I category? Each one of these numbers, one at a time, is going to go in the X sub I category. So let's add those in. So I have a 127, 126, 130, 125, 132, 129, 136, 140. Smiley face, are those on your paper? Now, this process is not difficult, but it is time consuming. So let me start off by saying that. There's no shortcut for this stuff, unfortunately, but it's really not that bad once we get going. So right here, what do I need in this column? I need to take my X sub I and I need to subtract the X with the line over it, which we know that that means the mean. So first of all, let's fill in this with our number minus. Let's do kind of like our blank equation here. Okay, so I'm just writing each number again with the minus sign, each number with the minus sign. But now I have to figure out the mean. That's really not that difficult to do. So let's come back up here. And how do I find the average? I'm going to add all of these together and then divide by how many there are. So how many are there? So how many total terms do we see up there? We see 8. So to find my average, note this is the X with the I above it, I'm going to add all of those terms together and I'm going to divide by 8. When I do that, I get 130.6. Are you still with me? We still doing okay? Okay, fabulous. So where am I going to put this 130.6? This was my X with the line over it, or my mean. So I'm going to put it right underneath my mean right here. Let's fill that in. Because the formula is telling me take each term individually and subtract the mean. Take each term individually, subtract the mean, subtract the mean, subtract the mean, and on and on and on and on and on we go. Okay, now this last column, what does it want me to do? It wants me to take the answer that I get from here and it wants me to square it. Can you maybe think of a good reason why it's wanting me to square it? Because what kind of a number would I get? If it's 127 minus 130.6, I would be getting a negative. You're right. But when I square it, it's going to make all of these terms become a positive final answer. So kind of cool. So let's check out this last column. So we would obviously have to work out what 127 minus 130.6 is, and then we square it and put that answer in this last column. So let me give you a minute to copy that column down, and then I did put the final sum down there of all those added together. Can you just give me a smiley face when you're ready? That's probably the hardest part about Illuminate, is I don't get to see you guys furiously writing, and I don't know when you are ready to move on. All right, so let's see. Why am I doing all that nonsense? Okay, let's come up here in the corner. So for variance or standard deviation, what they're telling me to do is take the sum of all of these terms squared. Guess what? We just did that. So this whole nonsense of the formula up here in the top, we just took care of it right here. That's what we were using our chart for. So when you guys see this crazy thing that says take the sum of each term individually minus the mean and square it, that's what we did in this chart. We took each individual term, found the difference between the term and the mean and squared it, then we found the sum down here. So this portion belongs right up there where it was highlighted. So let's see where we're at. We're almost done with this problem. So it says s squared equals, so we would have our 187.88, and on the bottom it says to divide by n minus 1. Well, what would that be in our case? How many total terms did I have? I had 8, so 8 minus 1 would be 7. By the time I work all that out, 187.88 divided by 7 gives us about 26.8. But notice that that's s squared, right? S squared equals 26.8. So to find just plain old s, you'd have to square root it, 5.2. So my variance, this is variance. Variance is 26 point, let me write it a little clearer. 26.8 is your variance. Your standard deviation is 5.2. Hi Alex, I'm glad that you joined us, but you really missed a lot. So you're probably going to be a little bit lost unless you just watch the recording. Okay, Lauren, how did that go? So the key that I want you guys doing is the minute that you guys see variance and standard deviation, you are going to, when you see this crazy thing, you are going to make this chart just like we did. And then our sum belongs in the top portion and the bottom portion is really easy to fill in. So you see this crazy thing, you are going to make this chart and it will make your life so much easier. So that's coming this week. And then I have one more thing to go over with you, but I see you typing a question, so I'll wait real fast. Oh, sure. So if they ask you for variance or standard deviation, that's what I looked on my paper. If they ask you for variance or standard deviation, you're going to make this chart. So if I was going to have something in my notes, I would probably say, I'd write these words down, variance, standard deviation, and then I would draw this chart, like this top part of the chart and just a blank boxes to fill in. That's what I would do. So let me give you just a quick minute to make some notes, add that to your notes. Sorry, the highlight kind of made it hard to read. Let me move some of those highlights for you. There we go. You still do need this formula because of the bottom, right? Because the bottom you do have to do an n-1. But I just wanted you guys to recognize that this crazy top part of the formula, you just make this chart. The sum of the chart belongs in the sum in the top. And we know that that makes sense because our sigma notation means sum. So when we sum up our cool chart, that belongs in the top portion of the formula. I also desktop shared this PowerPoint with you guys, so you can print this one slide if you want to and make some really good notes on it. All right, next we're going to get into sampling. Sampling, so the last part of the few slides is going to be really simple. I'm just going to ask you guys some questions. Do you have your textbooks handy? I want you to have your book handy. Can you go grab it for a minute if you don't have it handy, and I will wait for you? We want to be on page 512. If you could give me a green check mark when you have your book and you're on 512, then I'll know you're ready. If I were you guys, I would mark page 512 with a post-it note, like a sticky note, because you can use that on your tests and quizzes. If you notice on the left side, it gives you each of the kind of sampling. It gives you their definitions. And on the right-hand side, which I find even more useful, they give you a scenario of an example of what would go with each type of sampling. A sample is like when I would ask a group a question, and I need to know as my sample bias. Maybe I'm only asking seniors instead of asking the whole school. Well, you guys know if I ask a senior a question versus asking a freshman a question, I might get a very different answer. Samples are a small subset of the whole population. So if you think of the whole population, population doesn't have to mean the entire world, because maybe you're just talking about SCOA high school students, right? Then that would be a population. We use samples to collect data. Sometimes we do get biased data, and we'll talk about that in a minute. So a biased sample is when not all members of the population are likely to be included. So if I'm not getting responses from everybody, well then my sample is really skewed and the results that I'm getting are not totally accurate if I don't get responses from anybody. So let's go over some scenarios here. On page 512, again I would mark that with a post-it note, it gives you all of these different sampling choices. There are a few that are considered biased. So if you want to write these down or put a little sticky note next to these, convenient sampling is definitely biased. Voluntary response sampling is biased. And then sometimes you can make cases for a few of the other ones as well. So sometimes this is biased as well. So I'm going to give you a couple examples on the next slide. So think about what convenient sampling is. It's me finding people who are convenient for me to ask a question to, right? It's not me asking everybody. It's me just finding people who are maybe right in my path as I'm walking to work. So let's do a couple examples and then these will make more sense. Oh, where did my slide go? Where did my slide go? Did it disappear? Maybe I'll just have to read them to you. Hang on, let me look. Oh, here they are. Okay, so here's a couple sampling methods. A survey question online asks readers if they prefer one soft drink over another. My population is all soft drink users. So there's two things that this is asking me to do. First, identify which sampling method it is based on page 512. Then I need to state whether it's biased or not biased and identify possible sources of bias. So let me help you with the first one. A survey question online asks readers if they prefer one soft drink over another. You guys want to take a guess? Yes, it is biased. That's for sure. Do we know what kind of sampling method that would be considered? Good job. Yes, this one would be considered voluntary. Because think about this. On Facebook, I'm sure you guys are on Facebook, every once in a while down the sidebar you'll see, hey, take this survey, or after you buy something online, please take my survey. That's a voluntary survey. You don't have to take it. Anytime something's voluntary, your answers are going to be biased. Think about the kind of people who probably fill out that survey. Maybe they're giving you an incentive like $10 off your next order. Well, or maybe it's somebody who had a really bad experience and they want to leave that negative feedback. So usually when people ask a survey question, and it's definitely voluntary because they can't force you to do it, that means you're not getting the whole population to answer. Does that make sense? Nobody's going to force everybody to answer. It's just not possible. And again, it's biased because either only people with a really strong point of view are answering, or maybe they're giving you an incentive to tell them how good a job they did, like money off on your next purchase. Our next example, it says county residents are divided into sports fans and non-sports fans. Then 100 residents from each group are randomly selected and called after 6 p.m. and asked to complete a survey. So my population's all county residents. So first I need to ask myself, what kind of sampling is this? So notice the very first sentence, it says they're divided into sports fans and non-sports fans. One kind of sampling talks about dividing the population group into 2 or more groups. So that's considered stratified because you're dissecting them, you're putting them into groups. And if you just read the definitions, you'll be able to say, oh yeah, that makes sense. And what do you guys think? Do you think that would be biased or unbiased? Good job. Yes, I see what Lauren wrote. Yep, again, so this is kind of voluntary, and not only is it voluntary, but I'm only calling after 6. Do you think I'm going to reach every single person on my list if I only choose to call at one time in the day? I'm definitely not going to reach everybody. So that would definitely be biased because you're only going to get the answers from the people who pick up the phone. And even if they pick up the phone, they may not choose to still answer your questions and do your survey. So definitely biased. Okay, any questions about that? So when you take your quiz on this section, just keep page 512 open and you will be in a really good spot. No problem. Thanks, Lauren. The last thing I was just going to cover today was that there are 3 different types of graphs. You're going to have a bar graph, you're going to have a line graph, and I just wanted to remind you what those look like. So a bar graph would look something like this with bars on it. Couple key things to note. On each of your axes, they have to be in increments. So notice on the bottom, it's your grades. So 7, 8, 9, 10, 11, 12. On the top, it goes by 50s. 50, 100, 150. So whenever you're making a bar graph, you can't start at 0 and then jump to 1,000 and then jump to 1,000,000. You have to have good increments. So hopefully that makes sense. You have to have good increments. If you're doing all grade levels in a high school, you can't just leave out 10th and 12th grade because you're choosing to. You need to do, if you're doing grades, you need to include all grade levels. And then on a line graph, same thing. So just make sure, like this is snowfall in inches. This one's going by 2s. It needs to be consistent. So if you're choosing 2s, it has to be by 2s the whole way. And across the bottom, if you're going by months, you can't just choose to skip December because you don't want December in there. You need to be consistent. And that kind of wraps up our day today. So that's a wrap. Again, our week 17 question for essential question is, what does a histogram show you? We covered that towards the beginning of the session, so I will post the recording later so that way you can go back and watch the beginning. So thanks guys, have a great week, and just remember that even though those formulas look scary, please just do that little chart that I was showing you on that one really clear example and you should be just fine. So thanks.